The diagram shows a ladder AB of length 5.2 meters with its foot on horizontal ground and its top leaning against a vertical wall. End A slips along the floor directly away from the wall at a speed of 0.1 meters per second. How fast is end B moving down the wall at the instant that it passes through the point that is 4.8 meters above the ground? So let's call this X and this Y, and then this is dx dt, which is 0.1. So let's call this one dy dt. It's going to be sliding down, so dy dt will end up being negative, but dy dt should be measured in the same direction as y, in other words from the bottom to the top. Now by Pythagoras' theorem, we know that x squared plus y squared will be equal to 5.2 squared. What are we required to find? We're required to find dy dt when y is equal to 4.8. So we have dx dt, we want to get dy dt. If we differentiate this, and remember you could do this implicitly, we get 2x plus 2y dy dx is equal to 0. Rearranging that gives me dy dx is equal to negative x over y. And dy dt would be equal to dy dx multiplied by dx dt. So in other words, dy dt would be equal to 0.1, negative 0.1 x over y. Now, if y is equal to 4.8, then we know that x squared is going to be 5.2 squared minus 4.8 squared, so x would be the square root of 5.2 squared minus 4.8 squared. If you actually calculate that, you'll just find that that's 2. And so dy dt is negative 0.1 multiplied by 2 over 4.8. So we have negative 0.1. No, I have to use the other negative because otherwise it gives me my last answer, so it's that negative 0.1 multiplied by 2 over 4.8, and that's negative 0.0416. I've got second point in there, can't do that. So 416 recurring meters per second. Now it just asks for speed, so the sign's not important. So we'll say 0.416 recurring. I've missed a 0 out. Not having a good day with this, but let's get it right. 0.416 recurring meters per second.